Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for the function, determine where the critical point is a local maximum or minimum, sketch the graph of the function. So we are given this function f at x equals 3 times x exponent 4 minus 4 times x exponent 3. So let's start with the critical points. Now critical points are points at which the derivative of the function is either equal to 0 or undefined. So the first step here is to find the derivative of this function. So prime of f at x equals, so for the first term, we'll have to use the power rule. Now 3 is the coefficient of the term, so it will stay as it is. And for x exponent 4, as per the power rule, we'll move the 4 to the front of the term and we'll subtract 1 from 4. Minus, now in the other term, 4 is the coefficient, so it will stay as it is. And as per power rule, we'll move the exponent 3 to the front and subtract 1 from it. Now we can simplify this expression. So f prime of x equals, so we do 3 times 4, which is 12, and then x exponent 3 minus 4 times 3, which is 12, and then x exponent 2. Now we have to find the x values at which the prime of f at x will be equal to 0 or undefined. Now prime of f at x is a polynomial expression, so there are no x values that will make this expression undefined. So that means there are no x values at which prime of f at x is undefined. So we just have to find the x values that will make the prime of f at x equal to 0. So we'll sub in left side as 0 and then solve for x. So now we can do common factoring on the right side. So we can factor out 12x squared. So this is the factored form of this equation. And now we have to solve this equation. So we get two cases. So the first case is 12x squared equals 0. So we divide both sides by 12. The 12 on the left side goes away and we get x squared equals 0. And now we can apply square root to both sides. So on the left side, the square root and the square cancel each other out. So we get x equals 0. So this is our first critical number for this function. Now we can analyze the second case. So we get x minus 1 equals 0. And now we can isolate x by adding 1 to both sides. So the ones on the left side get cancelled out. So we get x equals 1. So this is our second critical number. Now we can find the critical points by subbing in these critical numbers one by one in the given function. So let's start with x equals 0. So f at 0 equals 3 times 0 exponent 4 minus 4 times 0 exponent 3. So 3 times 0 exponent 4 will just be 0, and same with 4 times 0 exponent 3. So f at 0 is equal to 0. So that means the first critical point is 0, comma 0. Now we can analyze the second critical number, which is x equals 1. So we should sub in x as 1 in the given function. So we can do it here. So f at 1 equals, so 3 times 1 exponent 4 minus 4 times 1 3. So f at 1 equals, so 1 exponent 4 is 1. So 3 times 1 is 3, then minus, so 1 exponent 3 is 1 and 4 times 1 is 4. So f at 1 is equal to -1. So that means the second critical point is 1, -1. So this function has two critical points. So we are done with the first part of the problem. Now in the second part, we have to determine whether the critical point is local maximum or minimum. So for that, we'll use the first derivative test and we'll find whether the function is increasing or decreasing on both sides of these critical points. So we'll use the number line method. So we'll start by drawing the number line and we'll show these critical numbers. So the critical numbers we got are x equals 0 and 1. 0. So these critical numbers divide this number line into three parts or three intervals. So we have to find whether the function is increasing or decreasing in these three intervals. And for that, we'll use a test value in each part. So on the left side of 0, we can use the test value -1. Between 0 and 1, we can use the test value positive 0.5. And to the right side of 1, we can use the test value 2. Now we have to sub in these test values one by one in the prime of f at x, not f at x. So we'll use this. So if prime of f at x is greater than 0 in an interval, that means the function is increasing in that interval. And if prime of f at x is less than 0, that means the function is decreasing in that interval. So let's start with prime of f at -1. So we get 12 times -1 exponent 3 minus 12 times -1 squared. So we get prime of f at -1 equals, now -1 cube is -1, so 12 times -1 will be -12. And then -1 square is +1, so -12 times +1 is -12, which is equal to -24. So we got a negative value for prime of f. That means the function is decreasing on the left side of x equals 0. Now we can analyze the function between 0 and 1. So we can use the other test value. So prime of f at 0.5 equals, so 12 times 0.5 cube minus 12 times 0.5 square. So now we can simplify this expression. So prime of f at 0.5. So 0.5 cube will be a positive number and times 12 is equal to 1.5. Then minus 12 times 0.5 square is equal to 3. So we get -1.5. So we got a negative value for prime of f. That means the function is decreasing between 0 and 1. Now we can analyze prime of f for the test value x equals 2. So prime of f at 2 equals, so 12 times 2 cubed minus 12 times 2 squared. So prime of f at 2. So 2 exponent 3 is 8. So 12 times 8 is 96 minus 2 exponent 2 is 4. So 12 times 4 is 48. And 96 minus 48 is equal to 48. So we got a positive value for prime of f. That means the function is increasing to the right side of x equals 1. So now we can use these results to find where the critical points are local maximum or minimum. So let's start with the first critical point at 0, 0. Now to the left side of 0, the function is decreasing, and to the right side of 0, the function is decreasing. So as we go from left to right, the function keeps on decreasing to both sides at both sides of x equals 0. So that means the critical point 0, 0 is neither maximum or minimum. So 0, 0 is neither local maximum nor minimum. So there is a very important concept you need to understand and memorize. Now we can analyze the other critical point. Now to the left side of the other critical point, the critical number x equals 1, the function is decreasing, and to the right side of x equals 1, the function is increasing. That means there is a local minimum at the other critical point. At 1 comma negative 1, the other critical point. So now we have answered the second part, and now we can sketch the graph of this function. So for that we can find the intercepts first, so that will make the sketch more precise. So we can start with x-intercepts. So for x-intercepts, we should sub in the function value as 0 in the given function. So 0 equals 3x exponent 4 minus 4x cubed. Now we can do common factoring. So we can factor out x cubed on the right side. So 0 equals so this is the factored form, and now we can analyze the cases. So the first case is x cubed equals 0, and we can apply cube root to both sides. So on the left side, the cube and the cube will get cancelled out. So we get x equals 0. So this is the first x-intercept. Now we can analyze the other case. So 3x minus 4 equals 0. Now we can add 4 to both sides. So the 4's on the left side will get cancelled out. So we get 3x equals 4. And now we can divide both sides by 3. So we get x equals 4 over 3. So this is our second x-intercept for this function. Now we can find the y-intercept. So for y-intercept, we'll sub in the x as 0 in the given function. So f at 0 equals 3 times 0 exponent 4 minus 4 times 0 exponent 3. So f at 0. So 0 exponent 4 is 0, and 3 times 0 is 0, minus, now 0 exponent 3 is 0, so 4 times 0 is 0. So f at 0 equals 0. So this is our y-intercept. So in point form, this y-intercept is 0, comma 0. Now we can use all of this information to sketch the function. So let's start by drawing the grid. So we can start by showing the critical points. So the critical points are at 0, 0, the first critical point we got. And then the second critical point is at 1, -1. So let's assume this is 1 and this is -1. So the critical point is here, which is also the local minimum. And now we can show the x-intercept. So x-intercept is at x equals 0, which is also the critical point, same as y-intercept. And the other x-intercept is 4/3, which will be somewhere here. So this is the other x-intercept. Now we can use the results from the first derivative test to sketch this function. So on the left side of x equals 0, the function is decreasing. That means as we graph this function from left to right, it should be sloping downwards. So like this. Now the function is decreasing between 0 and 1 as well. That means it will continue to slope downwards towards the local minimum. Now to the right side of x equals 1, the function is increasing. So we should make it slope upwards and it should pass through the x-intercept 4/3. So this should be the sketch of this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.